Welcome back to Alpha DevCon 2022. I'm Dave McCormick, your host, and I'm joined today by Nikos Kazantzis, who is our Senior Solutions Engineer here at Alpha Software. Today, Nikos is going to be going over auditing Alpha applications. In other words, keeping track of what's going on inside the application, who's using it, and so on. There are a bunch of built-in features in Alpha Anywhere that'll let you do this, and Nikos will be touching on those, as well as some other ones that can be built out. So let's get started. Hello, Nikos, are you there?
Hi, Dave. Hi, everybody. Yep.
I'm doing well. You want to pop up on camera for a second just so people can see you?
Sure.
All right. There you are. Fantastic. All right, I'm going to go ahead and make you the presenter. Let's see, make presenter. And you should see a dialog box on your screen. And I'm going to drop off camera here. So you should see a dialog box on your screen. You should be able to choose. I see. It's beginning to load. Fantastic. Or is it? Still not seeing your screen quite yet. Are you selecting it?
Just give me a moment.
Fantastic. And actually, we're going to begin. Actually, Nikos is correct. We are going to begin with a pre-recorded video, and Nikos will show up towards the end. I'm sorry, I messed this up. This is totally my fault, not Nikos'.
No worries.
Once again, like we've gone over yesterday when we were talking about playing videos, the video playback is a little bit louder than the rest of things. So if you have got a pair of headphones on, especially, get your finger near that volume button. And when I go ahead and play the video, you just want to be able to turn it down. So let's take it away. We'll be here for questions during the entire time, so you can type questions into the questions box of the GoToWebinar control panel. And we're going to get started right.
Hello, everyone. Today we'll be talking about auditing Alpha applications. So we're going to be looking at built-in and expanded custom methods to capture application behavior in Alpha Anywhere. Now, data auditing is a subject that we've been asked a lot about, and it's also a subject that we've dealt with internally while building apps and solutions for customers. So what are we going to be covering today is, first of all, we're going to look at the concept, what exactly we mean by data auditing and where it applies. We're going to be looking at the auditing targets, the subjects for the data auditing, and what we're going to be collecting as data. We will review what is available built in to Alpha Anywhere that is related to data auditing capabilities. And we're also going to look at how to extend the built-in capabilities to make auditing even more detailed as required per case and per project. So data auditing itself, the term may not mean the same thing to everyone. So to clarify what we mean here by application data auditing, we need to make a basic distinction between forms of data. So regarding data itself, there are two categories we need to identify here. First category is what we call application or core data. This is the data that is a structural part of the application. This is the data that users see, they access, they modify. So things like customers, orders, trouble tickets, users, inventory items. This kind of data is mandatory. It's always available in an app according to the app's purpose. And when we're talking about data auditing, we do not refer to that data, not directly at least. The other category is what we call process or context data. And this is information that describes the operation of the application, and either under the user's control or a series of system actions. These are things like recording timestamps of when users logged in or out, records of changes to core data by users or by timestamp, etc. This kind of data is usually optional. It's only available in our app when we specifically log it. And an app may be built without any kind of this kind of data at all and still function fully. This is the part that we're talking about when we refer to data auditing. Now, having said it's optional, there are many systems and applications out there that require data auditing as part of the app. So this is not a rule that applies in all cases. Now, what is the purpose? Why are we doing data auditing? There are four main reasons, possibly many more, but four immediately come to mind. One is to retain an audit trail of data transaction. What this means is to help us record how core data changed over time. And where this is especially useful is when we need to work back from a quote unquote bad state of an application in the data set to understand how it got to that state. And one common example is, for example, when we have a lookup table of statuses and we find one of those values suddenly during application use suddenly changed, and this affects potentially everyone who's using lookups from that table. So it is useful to be able to go back and see how and by whom that change was made, and this will either identify cases where that should not have been permitted, or cases where controls were not put in place to block people from inadvertently changing something that they shouldn't. So answering questions like who made that change and since when has it been in that unwanted state. The other scenario is retaining an audit trail of user actions. So not necessarily related to the data itself, but actually how users navigate and work through the application, what actions they perform, in what sequence they perform their actions. And this helps evaluate whether the features that have been built for that application are being used, and if they are being used in the way that the application developers designed them to be used, or they're being used in an unexpected way that may lead to issues. A very common use of data auditing is debugging. So one of the most difficult situations to be in when you're debugging an app is to have a case reported by users, and the standard approach when receiving a bug report is to try to replicate it internally, and in many cases this is challenging. Sometimes this is not possible to replicate, and in many such scenarios the difficulty lies in replicating the exact actions of the user, screen by screen and action by action, that led to the condition that resulted in a bug. So having audit data in that kind of detail helps to identify the sequences and the states of the application that exhibited unwanted behavior. So it helps us narrow down and get to the possible root causes quicker. And lastly, but certainly not least, is performing and logging performance metrics. So as applications are being used, the response times can vary widely across the different implementations. Even in the same implementation over time, as conditions change, as even the core data changes over time and data accumulates, we might encounter unoptimized situations. We might encounter situations that we did not plan for. And performance metrics help by giving us objective figures that would otherwise only be described by subjective data or descriptions. So receiving user reports that an application is slow today, or it's been slow for the past week, is an indication that there's a problem. But we would like to be able to do objective comparisons to similar situations and conditions in the past or in other such scenarios, and see and compare and actually get some more concrete figures behind the performance differences that people might be reporting and what they actually may be attributed to. Now, as per all of these concept and elements, we can now get some better idea of what would be the kind of auditing targets that we might be interested to include. So regarding data transactions themselves, we're talking about monitoring reads. We're talking about monitoring writes, all kind of writes, create, update, and delete. Capturing user activity. So in an alpha anywhere application with multiple components, which ones are being used? Inside a single component like a UX with multiple panel cards, which actual screens are being used, and the sequence that they're being used in, either navigating from screen to screen or performing actions within a single screen. Also, client information, things like what is the user ID if there's a login system of the user that is performing these actions? What is their IP address? Sometimes this helps to segregate groups of users between them and address problems more easily. Or even their device and client type. Are they working from a mobile browser or a web browser, and what type of browser? This kind of info is, again, specific to the action being performed, but there are also system-wide items of data that we might be interested in, like performance timing. So a list being loaded or a grid being loaded, how long does that take? Grid or a list is being synced, how long does that take? And there's some processing being done, server side, creating a report, client side, doing some calculation. How long does that take? Logging this kind of information, again, and keeping it in an audit table that we can keep a record of, helps us to manage some of the scenarios that we talked about earlier. So before we go any further into the details here, let's actually open up a sample application, just the UX, and go through some very standard and typical actions that one might do in a UX, similar to the kind of things that we described earlier, and see how that translates into loggable and auditable items. So I'm logging in here to this application. I'm reaching a main screen. I have a list that I can search by. So I'm picking my argument and I'm doing a query to get the list. I am going to this record and I am going to edit it and I'm going to save it. And I'm going to synchronize the list. And I am going to go to another record here. And I'm going to create a record in another table manually, just using some XBasic code. So that item was created. And I'm going to perform a custom action, just client side, the button there. And what I'm also going to do is I'm going to navigate back to customers and I'm going to create a new record. And let's call this test. And I'm going to save it. And again, I'm going to synchronize. So that is now synchronized. And then I'm going to pick this one and I'm going to delete it. And having done that, I'm going to log out of the application. So that is a very simple and standard walkthrough of a basic action or set of actions in an application. Let's now go see what data we could have collected from everything that we did so far. The first thing that we can do is recorded in a built-in feature of Alpha, which is called an audit table. So what the audit table does, it supports, first of all, both the grid and the UX. And what it does regarding data transaction is it does not record any reads, but it records writes. It records writes to SQL data sources. It does not support non-SQL data sources. And it records anything that has been done in an application via the standard built-in methods of syncing of grids and UXs. So if you have any custom XBasic code, this would not be automatically logged in the audit table. And out of the methods that are supported here, it supports grid save, data-bound UX submit, and a UX list control synchronize. Okay, so this is what the audit table captures. We're gonna see what it actually captured in a moment. Regarding the components used, remember we had a user action category of items that we'd like to be audited. So the audit table only records data during write operation. So during application usage, there's nothing being logged. But during write operations, if it's a data-bound UX, it tells us the name of the UX. And if it's a UX with a list control, it records the name of the UX and also the name of the list control that performed the sync. And regarding client information, again, only during write operations, it records the user ID, and obviously that happens only when Alpha Web Security is used. So let's take a look at how that table actually looks. So let me jump to the audit table and let me refresh. And I have enabled the audit table from the web project properties, and I'll demonstrate where that is in a moment. But let's see what this logged so far from the actions that we just saw a moment ago in the actual application. So you can see it recorded three things. Remember, in our walkthrough, we first did an update, and we updated the value of an existing record. And let me just switch to form view to show how that looks. So what this says is this user performed an update at this date and time on this field and set this value replacing this old value. It did it in this table with this primary key value. And the update was done from the UX component called auditing sample UX and the list control called customers. So this is a very rich set of info already captured automatically. And remember, we didn't need to write any code to make that work. All we had to do was enable the audit log. And after that, since we're using the standard sync method of the list to sync the data, the audit table records that automatically. It recorded two more actions. The insert action that we did of the test record, as you remember, and we also then did a delete of that same record, and that's also recorded here. Okay, so this is what the audit log recorded automatically out of our actions in the UX. You will notice that it did not record, as we mentioned here, it did not record our custom code for XBasic to insert a new ticket. So if you remember, we performed an action that said insert a new ticket into another table called tickets. And if I look at that, there it is. But the audit log did not capture that because this was done using custom XBasic. So this was not captured using that. Now, if we go to the actual project in the IDE and see how that was set up. So if we go to project properties, the audit table is enabled here in a section that's called audit table. Just enable it using this checkbox, and we provide a connection string for where it's going to be storing this information, and this can be created automatically and a field mapping done. And the expression for user ID, remember, it is also logging the user ID of who performed the action. There it is. So how does it know that? By default, it's capturing session.userid, which is actually grabbed from context security current user. So once that is set up, then this method knows where to grab the user ID and insert it into the audit table. Now, there's an important consideration here that we also show in this section about enabling and disabling the audit table. So as you saw there in the project properties, the enabler and disabling of the audit table is done via just a checkbox in the project properties in the ID configuration. There is no capability to change that setting at runtime. This means the audit table is a part of your running application, your running project. When you do a build and publish, whatever setting you've defined for the audit table, that stays with the application and the way it works until the next publish. And if you think about the reason for having an audit table, which is to capture a detailed audit down to the user and old value and new value and table and primary key for every change made in the database, then it makes sense and it's clear why that needs to be the case, because this is not a scenario that we would expect people to be turning the audit table on and off. Because the main purpose of an audit table of this form is not to do debugging. It can be used for debugging, but the main purpose is to keep an audit trail, like we mentioned. And an audit trail, for it to be complete and accurate, it needs to have the complete information from start till end of every transaction having been done. So that is why there's no provision here to enable or disable something like this. You set it up as part of your project, and it keeps running until you decide to disable it via another publish, another build. Let us now go and examine a second built-in option in Alpha Enable, which is a SQL query log. The SQL query log is a feature that supports, again, both the grid and the UX. This time, regarding audit target supported, it does support reads. It supports a grid reading data, UX reading data. It does not support a data-bound UX reading data. And regarding writes, again, against SQL data sources, it supports the Alpha Anywhere built-in methods for writes, grid save, data-bound UX submit, and UX list synchronize. It does not support custom X basic code as is out of the box. It does not log any user activity. It does not log any client information. It does log some performance information, and that is the time that each SQL query took to execute. And again, if we go see an example from the walkthrough of the app that we did against the SQL log table, this is what it captured. So you will see that every connection to the database that resulted in a query of some sort has been logged here. And we just switch to form view, for example. This is the original refresh of the list. Remember, we went to the list of customers and we chose a filter for the country, and we did a refresh to get the data back. So here is all of that recorded. So we can see the select statement, we can see the arguments passed in and the value of the argument, the result, call result success. If it was a failure, we would see the error text here. Built-in comments depending on the type of control that performed the SQL query, timestamp, and the time taken to perform this query server side. This is server side time. This is just the time for the database to perform the action and send the result back to the Alpha server. So we can see all of this has been logged automatically. Again, we did not need to add any code to make this work. The way all of this has been set up is, again, using project properties. We're going to the SQL log settings. We provide a connection string and table name for where that SQL log will be stored. The field map can be configured automatically or built manually. The data can be purged if we want, depending on a certain number of days, or leave zero to just leave everything in. Differently to what we had in the audit table, the SQL query log does have an enable disable flag that can be set and changed not only via the IDE configuration, what we just saw there, but also at runtime. And the way this is supported is there is another feature of Alpha, which is a global settings table, which is just a table that we point to in the database, which stores some basic global settings that we'd like to have access to generally in our application, no matter which UX or grid or other component we're calling from. And if there's a specific setting in that table and we give it the name here, so SQL query log enabled, If that value is true, then the every time a SQL query is performed, it is logged in the SQL log table by Alpha itself. If this is disabled, the entry is not entered. And this is checked at runtime, which means as something is running, you can enable it to debug or disable it to stop debugging. And just a quick look of that global settings table is here. So this is that first setting. Remember, global settings, SQL query log enabled, setting that to 1 or true, is what that built-in feature of the SQL log reads and decides whether this is running or not. If you change this to 0 at runtime, then every query that runs after that point will not log something in the SQL query log table. These two settings we'll get to in a moment. So again, the SQL query log, and as we saw there from the kind of data that we see inside, is mainly useful as a debugging tool or generally as a performance monitoring tool because it gives us detailed information. If we see a query, one of the classic things we do when troubleshooting or optimizing applications is we take this long list of queries running over days and weeks and months in an application and just sort of descending my time taking finding the longest queries to run. And we try to find discrepancies or things that immediately stand out. And the benefit of having the details here is that we can take this query directly. We can run it against a database natively, even outside of Alpha, using database tools, and compare and try to figure out where the performance difference might be coming from. Now, for the observant among you, which I'm sure is everyone, there is an entry in here that does not match what we just created, what we just described earlier in our mind map. So in our mind map, we said that the SQL query log by default does not support custom XBasic code. Yet in this table, in this record, we do see that custom XBasic that we ran that inserted a new record into tickets. And the reason that that is there is that we've augmented the SQL log capability with additional features, which we'll see as we go on and describe the kind of extensions that we can do here. Okay, so just leaving that aside to come to it in a moment. Now, there's one special item here, which is related to capturing location info, and I call it special because it is a category that overlaps both application core data, but also process contextual data, and usually, if an application is required to capture location data, it usually does it at the core level, which means capturing a user's location is part of the a standard data capture process. This is data that's needed at the core of the application. So just in case you aren't aware that this exists, this is a built-in option in the UX, both in data-bound UXs and in list controls. So in a data-bound UX, we have the after dialog validate event, and in there, in the save submitted data function, we have an option to automatically capture location for user. So we go back here and go to this UX, for example, and just go to the after dialog event and just quickly say here, save submitted data. We'll see that we have an option here to say store location information when record is saved, and we set that to yes. Then we get options for where to store that, update the location field, and we also have options to geocode, which means get address data from lat long. So this option is there in data-bound UXs, but it's also available in list controls. So if we go to a list control with a detail view and go to the other options here, at the bottom we have a submit location information option, and when we enable that, then again, location information is stored. So again, these are options that could be. So here's those control options said submit location info, and we do get the options geolocation and geocoding. Again, these would most likely fall under core data, which means that it would be captured anyway. If not, then these can also be captured and added to to audit table information manually if we like. So those are the built-in options that Alpha offers, and we saw a lot that has been covered already, and a rich data that is coming back to describe our data operations and our user operations. But there are, as we saw, still some gaps there. So if we want to examine what more we could do and enrich the audit data capture, then we would be looking at mainly two categories. The ideal scenario for capturing this kind of audit data in a component is to do it generically. And when we say generically, not to need to write logging code for every individual item that we would like to log. So, for example, if we have custom xbasic that does a SQL action, we would like to be able to use it against any custom xbasic code that we have. And the method that we do that is we can write a SQL wrapper where any custom xbasic that we want to run, we just point it to that wrapper function, and then we store the results in the same SQL log that we saw earlier. And you remember the example where we did see a custom xbasic query being stored in that same SQL log table. There's a sample script we'll look at in a moment to show one approach of how we could do that. There's a slight a tip here for the default Alpha SQL log table. The default SQL field is called SQL, but it helps with these custom actions to rename it to something that's not a reserved word. It will save you some trouble a little bit later on. So this is the custom xbasic SQL code logging, and again, we'll see that in a little bit more detail. The other generic option that covers and captures a wide variety of audit data is to capture AJAX callbacks. And again, we're talking about AJAX callbacks in the UX, for example. We're talking about a data-bound UX submit, a list control refresh, list control sync, a viewbox refresh, a custom AJAX callback that runs, custom xbasic code. So anything that starts an AJAX callback and brings a result back could potentially be covered via just a single script there, and then trying to figure out details from the arguments and the parameters of that AJAX callback. And that's exactly what we do. So we have two major client-side events that we can use. To capture the start of an AJAX callback, we have the can AJAX callback event, and the end of the AJAX callback is the after AJAX callback complete event in a UX. So just with these two events, we can capture what happened and store the results in a new table that we call the action log table, where we can store as much detail as we extracted out of this. Now, what did we extract? First of all, how do we know what we ran? If it's just two events that are called, can AJAX callback and after AJAX callback, how do we know what of these actually happened? And the answer is that we know because there are parameters that are passed in here automatically by Alpha that help us identify it. So, for example, the EXBasic function name is system populate controls from table if it's a data-bound navigate records event. If it's a UX submit, it's called system submit dialog. If it's a refresh list, it's called system refresh list. How do we know which list? There's a reserved variable in the datalog object called list ID to refresh. So just checking these parameters, which are almost all of them passed in automatically by Alpha, help us then to identify what it was. So in our log now, in our custom action log table, we can log exactly what that action was. Okay. Now, capturing AJAX callbacks again is that other generic method, but there's also a generic method for navigating inside a UX component, which has panel cards, using a generic event, which is the panel navigator on panel activate complete event. So whenever a user navigates from one panel card to the other, the on panel activate event fires. And we can use that to store, again, new records in our new action log table, using that handler to record the exact panel that the user navigated to using just this variable called this state active panel. There's a slight gotcha here that it only happens after navigation, so that does not fire for the first panel card on the app, which you assumedly already know. But if you do want to log that, then you can just use this property to get the active panel at that point. Okay, so this is how we can be generic and capture as much as possible from as few events as possible. But we also have specific capabilities, like how do we capture the client IP address if we'd like to store it? And the answer is, for both UXs and grids, there's a server-side event, obviously called on dialog initialize for the UX, on grid initialize for the grid, and request. There's a request object that is exchanged between client and server. There's a remote underscore ADDR property of that object, and that stores the IP address of the client. IP addresses can be valuable, but there is a consideration you need to keep in mind that depending on the connectivity and the way that the clients are accessing your alpha server, you might be getting the actual IP address of the machine, the LAN IP address, for example, if it's on the same network, or if it's a remote access, then you might be getting the router's IP address, which means if it's behind a NAT, then you would be getting the routers of that machine's IP address for a group of clients. For mobile applications, people on cell networks, then again you would be getting a unique IP, which might be changing over time as mobile devices move between various cell towers. Capturing user ID is again straightforward for cases where we have web security, both for UX and grid. We can use server side, we can use context security current user, and obviously this only applies when using alpha web security. Now, to see in that same component, in the same walkthrough that we went through before, how all of these affect it and can enrich the data that was being captured, let's go back to our database and let's look at that new table that we created. Remember, we had the SQL log that we saw here built into alpha with just this added feature by us for custom X basic. We had the audit table built into alpha, no setup again needed at all here. And then we also have our action log table. And for the walkthrough that we did of that app, based on just those generic event handlers plus the few specific ones, this is what we managed to capture. So notice that we're capturing from the start of the process, from when the user attempted to log in, and going through all of the steps until they logged out. And the kind of detail that we're capturing here is detail that we did not have in any of the other methods. So in this case, we're saying, here is the IP of the user that's trying to connect. Obviously, at the first one, just when the AJAX callback, just before it fired, obviously we don't have a user yet because we haven't logged in, because this AJAX callback was the login attempt. But then when we do get a response back and the user has logged in, then we do have a valid user. There it is. So this is now the after AJAX callback event. And now what we're also able to do is to time this whenever there is a can AJAX callback, which fires just before the event fires client side, the AJAX callback fires client side, and then when the response comes back, we can time these two and get the time elapsed from start to finish. Remember, this is an end-to-end result from the moment the user pressed login to the time the response came back from the server. So it took a little more than 1 second to go through login. Then we can see we navigated to this panel card. We did a refresh list as you can see here, and this took 600 milliseconds. We moved to another panel card called the detail. Then we moved back to the list. We refreshed, we synced the list, persist list data. So this took a second. Then we went to detail. We called our custom code, there it is, to create a ticket. We also clicked that custom button. Remember that just did a client-side action. This is also logged. Obviously, there's no time when there's no server-side action involved. Only when there's an AJAX callback that has a request and a result coming back is when we can time it and say time elapsed. So we went to the customers list, customer detail. We synced again. We went back to another panel card. We synced another time. You can see all the different times here. And at the end, we logged out. Now, just to go through how we actually built all this in our component, there are just a few steps needed, and we'll walk through the sort of overview here, then we'll dive into the actual component and see how that was built. So let's start with our JavaScript actions. There's just one setting here needed, a function called append to action log. Remember, action log is our new table, the one that's storing all the additional info that we are collecting that the standard alpha SQL log and audit table tables do not store. So this is our new action log table. So what we want to do is we want to set our component up to write to that action log table the additional info that we want. So first we go to our JavaScript function section, and just define a new function called append to action log. And it takes some parameters, the action type, the action target, and the value. And all we do is we just paste essentially this function into our component. Then we need to go to two client-side events. Remember, to capture the AJAX callbacks, we need to go to the can AJAX callback event and the after AJAX callback event. And we do two things. The can AJAX callback event calls the append to action log to log the action that's being done at that moment. Remember, we identify it from the parameters that are passed in to this section here, so we know what is being why that action why that AJAX callback is firing. So we append it to the action log, and we'll see how that happens. When the after AJAX callback event happens, we clear all of the recorded ones, and then we save that after AJAX callback result again. We do this for optimization reasons. So one basic question when setting up a custom action log, especially when it involves client-side actions that do not involve an AJAX callback sometimes, such as clicking a button, is how often do we write back to that action log table server-side in the database? Do we want to write each and every time? So every time we click a button, that just as a client-side action, do we want to write to the action log and do an AJAX callback? That would be performance-wise, that would not be ideal. So what we're doing is we're capturing every event that happens that we want to capture in a custom way here. And whenever there is an actual AJAX callback being fired for normal application reasons, such as a list refresh or a list sync, then at that point, we insert our action log data into that. So when the after AJAX callback event fires, which means the AJAX callback completed, and we've done those inserts, then we clear the buffer that we've kept so we can start adding new ones. Okay, so the can AJAX callback and after AJAX callback events are here. So here's the can AJAX callback event, and this is what it says. Essentially, it's checking what type of function came in and calling that append to action log function that we just created here, writing to it the parametric data that it determined from the parameters of the can AJAX callback event. Similarly, for the after AJAX callback, we do the same thing. And here is where we clear the buffer, the stored items in the action log, because the after AJAX callback, we just synced all of them to the action log table. So that's the client-side event setup. Remember, we also have a panel navigator global event to capture navigation from panel card to panel card in the UX. And again, we just need to go to one event called on panel activate complete. So we've got our panel navigator here. We have events. We got the on panel activate complete event, and we just store this. And this variable, this state active panel, is what gives us information about what panel we navigated to next. Okay. Now, server-side events have 2 points. The on dialog initialize event is what gives us the client IP, and we determine if the action log is enabled. So we are taking advantage of the same mechanism that Alpha used for the SQL query log. Remember, we have 0 or 1 to enable it or disable it at runtime. So we implemented in this version at least a similar flag for the action log, our custom table, to say, is this enabled, 0 or 1? And we've gone a step further here to say, well, if we are recording an action log, are we recording it globally for all of the components in our solution, in our application, in our project, or do we want to just target specific ones? So we can just list them here, comma delimited, if we want to log specific ones. If we want to do all of them, we just do star. And that would include all of them without us needing to mention them, especially if you've got a large number of components. But essentially, it works in the same way. So what the server-side events need to do is to actually check if the action log is enabled to continue with logging that information that has been collected already client-side into the action log table. So if we go to the on-dialog initialize event, here is our client IP. Remember, request remote _ ADDR. We also get the component name. Remember, we're storing also that in the action log. Here we have the component name. We also have the component alias, so we know where these actions are coming from. We could group them and filter them when we're checking through a long action log list. And here's where we check to say, well, is the action log actually enabled? And we've, at the first dialog initialize, we just run a blank one without needing to log anything, just because we want to get a result back of whether that is enabled or not. What this does is it calls an XBasic function in an XBasic module called action log sync. And this is what we have here in our XBasic functions here. So this is our function. We just set it up with wherever we need to point to store that table, similar to what we did in project properties for the SQL log and the audit table, the built-in ones. And we essentially, this is the function that takes the stored buffered action log details from the client and inserts them into the database. But it also checks to see whether the action log table is enabled or disabled each time, not only generally 0 or 1 here, but is it enabled or enabled for this specific component that just fired an AJAX callback. In this case, we're in the on dialog initialize event, so this happened only at the beginning, but we're also firing this again here on dialog execute. On dialog execute fires every time there's an AJAX callback. So it's one place that we can centrally manage all of the AJAX callbacks coming in and determine, is the action log enabled? Yes, then I do a storage of all that data and send back the response. So those are the steps to set up the server-side events. Again, on dialog execute is where we commit the data and we recheck if the action log is enabled or not. If it's enabled, it continues on, sends a response back to the client. The client continues to log. If it's disabled, it stops doing that. And the XBasic module has 2 elements. One is the action log sync, which we just saw here. The other one is the last piece that we haven't looked at yet, which is, remember we had a custom XBasic function. Let me show you that again. So remember we had a button on our UX that just did a custom insert here. So it called an XBasic function called create ticket. And create ticket, what it did is it just inserted a new row into the tickets table manually. So this is not covered by the alpha built-in options. SQL log doesn't cover it. Audit table doesn't cover it. But we do want to log it ourselves. So what we do is here in our module, we created a wrapper function for SQL queries called SQL execute and log. So whenever we need to log custom XBasic queries, then we build our query as normal, but then instead of saying cn.execute and then the SQL and the args, we pass in the connection string, the SQL and the args and the description of what we're trying to do, and call that wrapper function. So what that wrapper function does is it performs a SQL as it would have been done without this, but then it also logs the result of that action into the same SQL log table that Alpha normally uses. So that's why we're able to have a combined table of both the Alpha automatically logged actions from UX syncs and also the custom XBasic function that we used and we're writing into the same table. So summarizing, having this set of steps built in to your components, the standard XBasic module with the two functions that we saw, and the generic handlers with AJAX callbacks, panel navigators, and the server-side events, and individual, when the generic ones are not enough and we need to capture something specific, just going into a button that does something and just calling the append to action log function here client side, just to add this to the log, allows us to produce the kind of detailed logs and audit data that we saw in the examples. So that concludes our session on data auditing today. Again, for many reasons, the ones we discussed and possibly more, adding data auditing to an app is valuable. It's valuable during building the app, but especially during operation and live real-world usage of the app over the complete life cycle. So I hope that you found this interesting and useful. Thank you for joining and thank you for attending.
And thank you, Nikos, very much for that presentation. We do have a few questions here, which we can get to right now. Some of them that were asked were, it looks like, answered during the presentation. One had to do with, can you write to the same audit table that's used for the SQL audit table? In other words, can you have like one table in which you're keeping track of all of your audits? And it looks like you can, in fact, insert records using XBasic like any other table in your example. Is that more or less true there, Nikos?
Absolutely. So what we try to keep is to say, there are some certain fields that are configured for the SQL log table and the audit table. So when what we need to log matches the structure that's in those tables already, like we did for the custom XBasic function being called, we write that in the same table. There's no reason to do something different. But when we need to capture things that are not available in those tables, instead of expanding those, we just build a separate third action log table and we log them there. It's just XBasic in the end to log. If we need to store it in the same place, we can certainly do that.
Excellent. A couple of people pointed out that, in fact, you get this comment all the time, that mind map that you used, that presentation was pretty cool. They were just wondering what tool you used to do it.
It's called Mindomo. I'll mention it in the Slack channel so everyone can see it.
Fantastic.
Yeah,
and a related request is, can we get a maybe a PDF or a screenshot of that mind map all fully expanded?
So you'll get a link to an actual interactive version of the mind map, essentially the same one I was
even
using.
Better. Yeah,
read
cool.
only. And also a copy of the UX, so you have all the code that was there in the sample. So you'll have all both of those.
Fantastic. Someone was wondering about what the table structure is for the audit table. Is that in documentation, or is it built for you automatically, or is it just a couple
fields? So for both the SQL log and the audit table, there's an option there in the IDE in the builder to say just build it automatically. You just give it a connection string and a table name, and it just builds a structure for you and builds the mapping for you. So it's just a one click to make that work.
Excellent. Someone else was asking about what scope does auditing take place on? Is it taking place on the entire workspace level? Is it taking place on the web project level? Or is it down to the individual UXs or components, I should say?
It's down to the set of components that comprise the published project. So whatever it's running under, if you published a specific project in a workspace and you're running that and you've enabled the log for that, that's what you get from both the built-in features and what you would enable here, what we added. Remember, the custom items that we added are added to specific points in your component. So when you add them manually, you choose which components are going to be applied to, and also the generic, remember the global settings table will define if those are used or not actually in practice and be able to change at runtime.
Excellent. Someone else said they'd been using this feature since the beginning, but let me just get the wording here right. They weren't sure how you turned on they haven't seen the time taken field. Is that in the current release? Was that new, or is there a way that you activate that? So
in the existing SQL log,
yeah,
I believe that's been there. I can't say if it's been there from the beginning, but it's certainly one of the
been there a while.
Built-in options that the wizard gives you. The only thing to sort of take note there is, depending on the database that you're targeting in your connection string, if the field that's created is not a float field or decimal field, you will lose accuracy because it's only going to be storing whole seconds. So the only override you might want to do is if for some reason the automatic wizard created an integer type of field for that for the time taken, you just want to switch that to decimal to make sure you have all the accuracy.
Excellent. Another question is, well, we have a couple on documentation. What documentation is available for auditing? We should be able to get that into the Slack channel. I think we can find those links for you. But one of them is, are there specific XBasic functions that deal specifically with auditing, or are you just sort of using the regular XBasic functions for writing to databases when you're?
Yeah, just regular ones.
Okay, great. So it's not like the security tables where you're never supposed to touch them directly with SQL, and instead you go through functions.
No, right. Again, the action log table is something that we created customly for this requirement. So we're writing to that at will, and we chose to write to the existing SQL log table only when the structure absolutely matches. So we don't want to change the default structure that's there that Alpha expects and uses for its built-in auditing.
Right. I suspect there would be no harm in adding a field to that table, as long as you weren't changing a type or anything like that.
Yeah. I don't think that would be an issue. Yeah, you're right.
The next question is, someone is interested in using, you had mentioned that this is a great way for ongoing operations, seeing what the performance is and so on. It can also be used in development during bug testing and things like that. Someone said they've got a grid, and sometimes it's running slow, sometimes it isn't. Is there a way that you could sort of meter those sorts of operations to find out what part of my grid is slow? Like, in other words, what's going on. I can imagine, I guess, scenarios in which you've added into those on submit events and so on, the quick logging saying, user A did this action at this time and it took that long.
So yeah, the immediate distinction that you will get from what we showed just earlier is, are we talking about a database query that is slow? Right. Or are we talking about some other part of the end-to-end process that's slow? And to do that, we have the combination of the SQL log, which tells us just the raw database time. So if the grid took 10, or the UX took 10 seconds to refresh, and we see a SQL log entry of 9 seconds, you know where to look. You take that SQL query as you see it in the SQL log, you run it in SQL Server Management Studio or whatever else you're using on the database, check your queries directly there, and try to optimize your queries at database level, because that's where your bottleneck is. If you see a query time of 100 milliseconds, and it's taking 10 seconds for the component to load end to end, you're looking now in your component. You start to break down how your component is built. Is it doing additional queries, which would also show in things like the action log if it's an AJAX callback, for example. And going in that direction, at least to separate where you're looking first, and then optimizing that part.
That is terrific. Nikos, thank you very much for presenting. We are out of time. Again, if anyone has more questions, you can always send them to guides, GUIDES @alphasoftware.com. Coming up in 15 minutes is our next customer showcase, this time with Larry Rapito from Black Ink. He's a technology consultant there, showing off the Easy Track booking system. I think you'll find this interesting. It's a short little 30-minute presentation. Hope to see you back in about 15 minutes. Thanks again, Nikos. Thanks, everyone.
Thank
Bye-bye.
you. Thank you all. Bye.